Okay. Can you hear me? Okay. Hello everyone, welcome to my class. Today, I'm going to talk about shared libraries. First, we'll learn the overall process of building a program. And then, we will describe several issues when we are building a program or an application. Building a program. This picture shows the procedure of building a program. Can you see the core component in this picture? Compiler, assembler, linker, and executable program. Once again, compiler, assembler, linker, and executable program. These are core components. These steps are the process of building a program or an application. The first step is compiling step. In this step, the compiler converts the source C files and header files into a low-level assembly language code. Who makes the source C code and header files? Human. That's good. Human. We usually make the source code and header files using the development tools. They are similar to the human natural language that is called a high-level language. However, the computer machine cannot understand what they are. So, we have to convert the high-level language code into the lower-level language. That is called an assembly language. Okay. The second step is building a program is assembling. In this step, the assembler converts the assembler language code into the object code. The object code is a machine language code, which is for the computer machine. So, the computer machine can understand the object code. The last one is linking. The third step is building a program is linking. In this step, the linker makes an executable program. By linking several object codes into an object library. Commonly, the term linking is used to describe the use of the linker to combine one or more object codes into a single executable program. Okay, the linking. Until now, we have learned the overall process to building an executable program. Once again, compiling, assembling, and linking. So, we got the executable program. Now, we will learn the way of building a program on the command line interface. On your Linux systems. We are looking at the command to compile source C files to produce corresponding object code, object files. Okay, let's see the line. Prompt in your prompt, gcc -g -c and your program code. Program.c, module1.c, module2.c, and module3.c. So we have 1, 2, 3, 4 program source code. Okay. GCC means here is a command, and then -g and -c are options. The -c means compiling. -g means, what is it? -g. -g means debugging information in compiled program. And then link all of these object files together to produce the executable program. GCC, -g, and -o, -o options. Okay, -o options. You use -o options to link. PROG. PROG means the name of the executable program. And then prog.o, module1.o, module2.o, module3.o. Okay, .o means object files or object code, which is for the computer machines. So the linking means to link all these object files or codes together to produce the executable programs. This process is to build a program, compiling, assembling, and linking. So we got the executable program. We have 4 source code in C and 4 object code. Next, however, let's think about the case which is we have a large number of object files, more than 4, 5, 6, 10, and more, a large number of object files. We must name all of the object files during the link. That is tough for you. That is tedious jobs. You have to name, call, editing all of the object files on your command line interface. So we can group a set of object files into a single unit known as an object library. Single unit. Several object calls include several functions, library functions. Okay, object library. Object library classify 2 types. One is static, the other is shared libraries. What is static libraries and what is shared libraries? First one, static libraries. It is also known as archives. Archives files. We can place a set of commonly used object files into a single library files without needing to recompile the original source files when building a program. It's good. How to do? We just specify the name of the static library. It's very simple. We just specify the name of the static library. By convention, the name of static library forms lib and then name and then .a, end with .a. Start with lib and you write down the name of the static library and with .a. So put together library name .a. This is the name of the static library by convention. Let's see the line AR R library demo.a. Okay, AR means comment. R means AR's options. R means replace options. lib demo.a means the name of the static library. And then these are the object files. This line means 3 object files into a single library files named library demo.a. Library demo.a include these 3 object files. And then we link a program using a static library. Let's see the lines. There are 2 lines. The first one is gcc-g-c program.c. That's a C option means compiling. The second line gcc-g-o prog and prog.o libdemo.a. Okay, dash G means debugging information. Dash O means linking a program, executable program named prog. So prog.o and libdemo.a will be combined and archived to the executable program named prog. This picture shows the overall process of building a program. Once again, there are 3 parts: compiling, creating a static library, and linking. We will use these modules several times because they are very common and very useful modules. Thus, it will be better to group these modules into a single unit. The single unit is called the static library. We just use C option in order to compile a program and 3 common modules. So we got 4 object files which are ended with .o. Next, we just use AR command, archive command with R option. R means replace or create option in order to create a static library which is ended with .a. So we got one static library named libdemo.a. libdemo.a includes 3 common object models which are ended with .o. And next, we just use O option in order to link a program using the static library. So we got the executable program named PROG. That's it. Until now, we have learned the way of building a program using the static library. Perhaps several different programs would use these modules because they are very common, are very useful things. However, each program has its own copy of these object modules. This makes redundancies. Redundancy is not good. That is to say, disk space is wasted storing multiple copies of the same object modules. It would be considerable because of huge wastage. One more thing would be occurred. If several different programs are running at the same time, then each program holds separate copies of the object modules in virtual memory, thus increasing the overall virtual memory size. As you know, the virtual memory is one of the limited computing resources. And there is another shortcoming in the static library. If we need to change one of the object modules because of its security problem or bug fix and so on, we have to relink all programs using that module. This is very tough. This is very tedious jobs for us. To overcome these problems, shared libraries are needed. The key idea of a shared library is that a single copy of the object modules is shared by all programs. How? How can I do? The object modules are not copied into linked executable programs. Instead, a single copy of the library is loaded into memory at runtime. When the first program requiring object modules is started. When other programs using the object modules are later executed, they use the shared library at the virtual memory. Okay? The use of shared libraries means that executable programs require less space on disk and virtual memory. In addition, shared libraries provide the further advantages. Overall program size becomes smaller because the shared library can be excluded in the program. It is why the shared library are already in use by the first program. So the programs can be loaded into memory and started more quickly. There is another advantage. It is possible to make the change to the object modules without requiring programs to be linked in order to see the changes. Very good advantages. And then, how can we create a shared library? Let's see the line. In the prompt, we can see GCC command with -g, -c, -f, PIC options. -g means debugging information. -c means compiling. -f, PIC means the compiler should generate position-independent code. Position-independent code. That is to say, the compiler generates code for operations such as accessing global, static, and external variables, accessing string constant, and tasking the addresses of functions, and so on. This allows the code to be located at any virtual address at runtime. That means position-independent code. Position-independent code. And then we are looking at the second command. gcc-g-shared-o libdemo.so and the object files. -shared option create a shared library. -shared option. By convention, shared libraries have the prefix lib and the suffix .so. .so means shared object. In order to use a shared library, we have to perform additional 2 steps. Step 1. It must have a mechanism for identifying the shared library at runtime. This is done by embedding the name of shared library inside the program during the link phase. Embedding the name of the library inside the program happens automatically. Good. We just specify -o option in the GCC command. This command is embedding the name of the shared library inside the program. That's good. And step 2. At runtime, there must be a mechanism for reserving the embedded library name. That is to say, we need a mechanism for finding the shared library file corresponding to the name specified in the executable program. This mechanism is called dynamic linking. Dynamic linking. The dynamic linking is a task of reserving, finding the embedded library name at runtime. It is performed by the dynamic linker. Dynamic linker is also known as dynamic linking loader or runtime linker. The dynamic linker is supported by the Linux operating systems. Let's see the picture step by step. As you can see, the name of the shared library is embedded inside the program. This task is performed by the linking step. When we execute the program is loaded into memory and the program will be processed. At this point, that is, at runtime, the dynamic loader examines the list of shared libraries embedded inside the process. The dynamic loader is itself a shared library named ld-linux.so.2. LD. LD means dynamic loader. The Linux operating system supports dynamic linking mechanism using dynamic loader. Very good. The dynamic loader is finding the shared library in the common standard directories. Normally, the common standard directories means /lib and /usr/lib. If the dynamic loader finds the shared library, it loads the shared library into the memory. If the dynamic loader cannot find the shared library, it occurs the error message. For example, cannot open shared object file, no such file or directory, like this. It is commonly occurred when there is no shared library in the standard directory. So we have to move the shared library into the common standard directory. For example, /lib and /usr/lib. Okay? Okay, today's lesson is about the fundamental of shared library. We have learned the static library versus shared library. That's it. See you the next time. Goodbye.